So, how to manage multiple test environments in a hyper-connected cloud world? That's a bit of a mouthful of a title. Before we get into it, I'd like to talk a little bit about myself. My name is Abraham Marin-Perez, as you know. I am an independent consultant, although I do most of my business with Equal Experts. They very kindly agreed to spruce up my presentation. That's why you will see the logo over there. But I'm actually independent, but it does look much nicer this way. You should have seen the previous version. It wasn't good. Anyway, other than consultancy and development, I'm also an author. I'm also a public speaker, obviously. And I like to consider myself an adventurer. I like to try new things. This is the last one on my belt. I tried flying an airplane a short while ago. It was a very interesting experience. It was both exhilarating and terrifying. And if you ever have the chance to do it, please do, because the views are fantastic. But at the same time, the feeling of having this tiny cabin and knowing that there's nothing around you other than physics, it's interesting. Anyway, enough about myself. I'd like to start with a disclaimer about what this talk is not going to be about. Because whenever you talk about managing test environments, people think you're going to do some kind of tutorial on Docker or Kubernetes or Amazon or Azure or whatever your cloud environment is. So that's not what I'm going to do today. If you were expecting any of these tutorials, then I'm sorry. Just leave quietly through the back. And if you still need one of those, go online. There are plenty of those, very good, much better than what I could do. So your needs will be covered that way. What I'm going to talk about is the cost of having multiple test environments. And more particularly, I'm going to be talking about the different types of costs: operational, reputational, functional, and obviously economic. There is always money involved in these things. I'm going to be talking about 3 issues. The first one is filter management. And we're going to be solving that by what I call the universal filter flags. The second one is very related to the first one, and is test management, basically how you manage your test when you have multiple filter flags. And we're going to solve that with meta automation. And then finally, this is where I'll spend most of my time, I'm going to be talking about environment proliferation. One thing that we'll see is that now that we have Kubernetes, Docker, et cetera, it is very easy to actually spin up new environments. And that means we have a lot of them. And with that, we have new problems. So we actually need to look back at rationalizing them, seeing if we actually need all of them, and removing the ones that we can. Let me try to guess what your situation is. I'm assuming we all have a microservices environment. Yeah? Raise your hand if you do. Okay, few people didn't raise your hands. Who has a monolith? Oh, poor souls. Don't worry, a monolith environment is a microservice environment where you only have one service. And micro is just relative. So anyway, assuming you have a microservices environment, your architecture will look something like this, right? You have a bunch of services talking to each other, et cetera, et cetera. In this picture, I think there are about 13. Your situation might be different. If you're very greenfield, you might have 5. If you're more advanced, you might have 50. So let's do a quick survey. Who has, let's say, more than 10 services running in production? Yeah, quite a few hands. More than 50 services running in production? More than 70? More than 100? I'm getting scared now. More than 150? Okay, so less than 150. Do you two go work together? I think, okay. What is your number of services? Roughly 120. Does anybody have more than 120? No, so you guys are the winners. You are, actually. What's your name? David and? Punit. Right, David and Punit, you're going to get a prize later. So that's all your thought. Anyway, so this is, let's say, a simplified picture. You just multiply this times 10, and then you get your environment. But this is actually not really what you have, because this is just one of the instances. This is just one of your environment. Let's say this is production. But then you also have staging, which is an absolute replica of everything you have. And then you also have, I don't know, performance testing. And then you also have your functional testing, right? So whenever you create a new test environment, basically you're getting your entire architecture, your entire set of microservices and replicating it in one again. Which means that whenever you think of the complexity of your picture, you actually have to mirror that as many times as environments that you have. And this is what the problems really start happening, because we usually tend to look at the simplified picture of the one instance, but we don't have one instance, we have many of them. How does this problem of having multiple instances of our system affect, for instance, feature management? Again, this is your picture, and you're creating a new feature, and you want to make sure that you control when you make that new feature visible to users. So what do? You create a feature flag. Now, we are all very agile and advanced and cutting edge and all that, so we've probably done some, domain-driven design, and we've, created boundaries between our services and all that. So whenever we want to create this new feature, we make sure that all the changes that we need to do are contained to a single service, right? So that feature flag is going to be, for instance, there. It's just going to be in one single place. And then whenever we want to enable that new functionality, we just go to that service, we change the config, we enable the flag, and that's it. Our new feature is enabled in production or whatever environment you are enabling it in. Now, that's ideal. Unfortunately, sometimes this doesn't quite happen because of whatever the reason, you didn't foresee changes or whatever, but sometimes your new feature doesn't need one feature flag because it doesn't affect one service. It actually has changes in, let's say, 4 different places, which means you need 4 different flags, one in each of those services, because each of those services have their own config, which means you need to handle them independently. So you have 4 different places when you need to make a change. And if you're unlucky enough, you don't have to worry just about enabling or disabling all those 4 flags whenever you want to enable or disable the functionality. You also have to worry about the order, because if you do it in the wrong order, maybe bad things happen. So you need to make sure that whenever your QA or whoever is enabling the functionality, you need to tell them, enable these flags in this order, and if anything bad happens and you need to roll back, then disable them in this order as well. And again, that doesn't happen just in one environment. That happens in your production, in your staging, your performance, your functional testing, etc. So when you think you have one feature flag, you actually have 4 of them because it's spread in 4 different services, but you actually have 16 of them because they are spread in 4 different environments. And then if you're developing more than one feature at the same time, let's say you're developing 3 different features in parallel, then you have 48 different configuration items that you need to handle. And when you have that many configuration items that you need to handle, sooner or later, you're going to make a mistake. If you're lucky, that will be in a test environment. If you're not lucky, it will be in production. And it will probably take you a while to realize that you just enabled 3 of them, and the 4th one you didn't. The way to fix this is by having universal feature flags, or as I call them, feature flags as service, or FAS. This is to distinguish from traditional FAS, which is function as a service. No, this is feature flag as a service, so there's a strong F there, it's a FAS. The idea is very simple. Instead of having your feature flags spread in 4 different places, 4 or more whenever services are impacted, you actually concentrate that in a new service, which is going to be the feature flag service. And then whenever a service needs to have a branch of code, or 2 branches of code that says, if my feature is enabled, I go this way. If my feature is disabled, I go this other way. Instead of managing that locally in that service with an if and a configuration item, you actually manage that in a different service. So what you do is you make a call to a different service, the one that actually handles the feature flags, and say, hey, is this feature disabled or enabled? And if the other service tells you it's enabled, then you go one way. And if the other service tells you it's disabled, then you go the other way. But the point is, you manage that enabling or disabling in one central place. First, that makes operations much simpler, because whenever you want to enable your feature flag, there is only one place when you need to make the change. Again, for disabling it, there is only one place when you need to make the change. It also has the added benefit of you can make changes without having to restart your services, because these are just making REST calls, HTTP calls to a service. So whenever you change the config in the feature flag service, everything else is updated automatically. Another benefit that it has is that when you create this service, you can actually have an additional endpoint that tells you the current status of the functionality. So you have a centralized place to check the status of your functionalities. So you could say, hey, give me the current flags, the values of the current flag, and then you get a very nice report. You script this, you run it in all environments, and you have a quick way to see at a glance the state of functionality in your entire estate. You get more control about what you have enabled and disabled. You get easier operations when you need to enable or disable functionalities, and you reduce the probabilities of mistakes. Now, if creating a service for managing feature flags sounds like a bit new to you and you're not quite sure how to approach it, etc., it's okay. You don't need to start from scratch. A while ago, I partnered with Daniel Bryant, and we wrote this book, Continuous Delivery in Java. We explained a number of ideas, and to try to showcase the ideas that we present in the book, we created a GitHub repository where we present many of these things. Is this recorded? Okay. Anyway, let's edit that out. Among some of those ideas, there was a feature flag as a service. You can see there. The GitHub repository is open source, is public. You can check it. You don't need to buy the book if you don't want to, although, David and Puni, your price is one copy of the book. There you go. 120. That's good. So anyway, if you'd like to see an example of how to build a feature flag as a service, that's one example. You can take a look. It's written in Java, but it's actually very simple. And if you do another programming language, that's fine. You can probably translate it. If you still don't want to do it, that's OK too. There are many commercial operations, off-the-shelf products that you can use. One of them is Launch Darkly. It's exactly what I just described. It's a bit of it's a website where you can define your feature flags, and then there are snippets of code to integrate your code with that feature flag management. It works with pretty much any programming language that you can think of. It works with any platform, with websites, desktop, mobile applications, whatever. And it creates very nice reports that you can present to your stakeholders to say, this is what we currently have in production. It even gives you statistics of how much each of the features has been used, et cetera, et cetera. So again, if you are a bit concerned about doing this idea of feature flag as a service, start with one of these off-the-shelf products, and then you can just hit the ball running. So that's about feature flags and feature management. Let's go to the second of the topics, test management. Again, when you are developing features, you need to be careful with how you test them, because in different environments, it will be enabled or disabled, which means that the criteria or the behavior that you need to test will depend on whether the feature is enabled or disabled. So you typically will have different sets of tests, some of them that test the behavior of your system when the feature flag is on, and some of them that test the behavior of the system when the feature flag is off. And typically what you would do, or what I've seen organizations do, is the QA engineers are responsible for going and checking which functionality is enabled in which environment, and then going and enabling or disabling one set of tests or the other. And one of the most common sources of problems that we have, one of the most common reasons for the automated test to go red is because someone enabled the functionality but didn't tell the QAs, which means the QAs were still running the tests for the functionality being off, which means obviously the assertions are all wrong because that's not the behavior that we are expecting. The solution to this is actually very simple, which is make your tests, well, it's, again, going too far. It's about managing your test automatically. It's about automated test management, or like I said before, meta automation. You're basically selecting your test automatically. And the idea is your test suite, your automated test, has to be a client of the feature flag as a service itself. So before you start your tests, the test itself will talk to the feature flag as a service and will say, hey, which functionalities are enabled or disabled? And based on that, then you enable or disable one set of tests or the other. The actual mechanics of how you do this will depend on the testing tool that you're using. Here are some examples of how you can do it with some popular testing frameworks. If you have n units, you can use categories. If you have JUnit 5, you can use environment variables, for instance. There's an annotation that is enable if environment variable, and then you can set up the environment variable to one value or the other. If you use Scala, then you can use assumptions, and again, you just set the value of the assumption depending on the filter flag, etc. So essentially, before running your test, you have a little script that goes to the filter flag service, grabs the current value of the filter flags, then set up the necessary environment variables or whatever you need, and then you start your test. And your test will automatically select the tests that you need to run depending on the behavior that you have enabled in your environment. And that way is how you achieve meta automation. You have automated the automated tests that you need to run. Now that leads me to the last part, which is actually the longest. Which is about your environment proliferation. It's the fact that we have so many of these environments. Again, this is a picture. I'm showing 4. It could be more of them, or it could be fewer of them, depending on your particular organization. Some environments that you could have are, for instance, obviously production. I guess you have a production environment. You could have staging as the place where you run your regression tests. You could have a full integration environment where you test all your services, including the third parties that you don't have control of. You could have what I call an owned integration environment, and the owned integration environment is basically you test the components that you own, so you mock out the third parties and you test everything else. That's the difference between full integration and own integration. You could have a performance environment where you just do your performance testing, etc. You could have anything else. Now, you may think, yeah, I need all of this. Why are you talking about that, Abraham? Well, for several reasons. First of all, because this costs money. Yes, it's very easy to start creating new environments because we have Kubernetes or whatever, but every time you start up a new set of services, those are virtual machines that you need to pay, and at the end of the month, your bill is going to continue increasing. Now, it is so easy these days to start creating new things that sometimes we actually lose sight of what we're paying for. This has got into an almost comical situation where some people have made a career out of analyzing your AWS bill and then explaining it to you. One of those people is Corey Quinn. If you don't know him, start following him right now. He's got a podcast, he's got a blog, he's got a very funny tweet feed, and he's an absolute trove of information of anything related to AWS. So start following him, and you will realize that actually things can get pretty complicated pretty quickly. Now, you might be saying now, Abraham, I got 99 problems, but money isn't one of them. Okay. Well, first of all, lucky you. Second of all, money is not the only problem that you may have. Whenever you have multiple test environments, that means more moving parts. That means more components. That means more things that can go wrong, and therefore more things that you need to look after. That means more time spent firefighting, investigating, solving problems, trying to come up with new ways to automate the solution to problems that you are having, etc., etc., etc. That's why these days there is so much emphasis on running lean, because every second that you're spending on something that is not your core business is a second that you are missing to further your core business. It's a missed opportunity. So for this reason, it's very important that you actually have only what you need. And if you don't need a particular test environment, even if you don't care about the cost of that test environment, you might care about the time that you're spending and the effort and the distraction that that test environment is giving you. So for all those reasons, we're going to talk about how to rationalize, how to eliminate some of those test environments, how to check whether you actually need them, take a hard look at them, and if you don't need them, then get rid of them. This is why I call this section the fat trimming part of the business. So let's go through all the environments that we have and see if we actually need them or if we can do without them. Let's begin with production. Do you need a production environment? Yes, you do. Right? If you don't have a production environment, you might as well just close the shop and go home. Okay, so I'm sorry, you're stuck with that one. Staging. Do you need a staging environment? Okay, good. Next. Okay, let's go why. Usually, a staging environment is used for regression testing, right? It's not an environment that you use to test your new behavior. It's usually an environment that you use to make sure that the existing behavior is still what you expect it to be. And we need that because if we go back to our feature flags, we may have a particular set of configurations in production, and then we need another environment that exactly replicates what we have in production. So then whenever we make code changes, we have a place that mimics production, and then we test that we're not breaking anything. That's basically the purpose of staging, is not to test new things, it's just to verify that the existing things are still doing the same thing. And we need that because in earlier environments, we will probably have a different set of flags. So then that's not telling me whether I have broken something or not. Because if I am making my tests in earlier environments with a feature flag on, then I don't know if my system is still behaving as expected with the feature flag off. I need a different environment to test that. Now, that's only a problem precisely because we have feature flags, we have feature toggles. If we didn't have them, then there's nothing to mimic, which means we don't need a staging environment. Working without feature flags sounds a bit unorthodox at this point, but actually, when you look at the origin of feature flags, he's Martin Fowler talking about them about 12 years ago. He already said back then, try not to do them. And when you start thinking about why you're doing feature flags, you realize that there might be alternatives. Now, some reasons why you might be doing feature flags or feature toggles. One, because the functionality that you're developing is so big that there's no chance you can do it in one go. Therefore, you need to keep building your functionalities little by little until everything is ready, and then you enable it in production. And the answer to that is, well, maybe you need to break down the functionality into smaller bits that you can actually enable in smaller chunks, and you don't need a feature flag. You can just enable them as they're ready. The other reason why you might need a feature flag is because you're developing a functionality now, but you don't want to enable it yet. You want to enable it at some point in the future. And the answer to that could be, why are you doing it now? Maybe you can focus on something that is valuable now, as opposed to something that will be valuable in 3 months, etc. So there might be many different reasons why you're doing feature flags. And the answer is, check very hard whether you actually need them or whether you can change your work practices so you don't have feature flags. And if you don't have feature flags, you don't need a staging environment. And that's an entire set of services, 120, that you knock out the park and that you don't need to pay for anymore. So that's one, staging. How about the full integration environment? Oh, I like this. It's almost like Panto. This is a typical architecture diagram of a full integration environment, right? You have your components with your services, your queues, your databases, and your third party. The third party is the one that is making you have a full integration environment as opposed to an owned integration environment, right? So that boundary is full integration. This boundary is your owned integration. Now, if you look at this, you have two nested levels of testing, which implies a lot of duplication. And in IT, we don't usually like duplication. We try to get rid of it. So that's what we should try to do here. Get rid of that duplication. Get rid of those two nested levels of testing. And we can do that by changing this with a chained level of testing. So instead of having the owned integration environment, and then at a higher level, the full integration environment, we have the owned integration environment, and then we just test the connection to the third party. So typically, in our own integration environment, we are substituting the third party with a mock. And now the only thing that we need to do is make sure that the mock is actually a good representation of the real thing. And if we do that, then we have tested the same things, but without the need for a full integration environment. This chained connection, this connectivity test is something you can do with many tools. There are many things out there that can help you create something that mimics a third party while also checking that your mock is the same thing as a third party. These are just some of them. You can use this, you can use others. If you don't know how to use them, or if you'd like a bit more information on how to do that, I do not have time today. However, I did do a talk a while back with my partner, Daniel Bryant, and we went through this and a bit more. Actually, the last couple of slides were borrowed from that other presentation. So if you check that out, then you will see how you can create this chained level of environment. And we talk about defining levels of isolation in testing, etc., which is going to enable you to get rid of that full integration environment. So if you can design your tests, your automated tests, so you chain them as opposed to nest them, then there's a full, then you can get rid of the full integration environment. And that's another one that you get out of your build. How about your own integration environment? Now, it might look like this is the last one that you have, right? There are no other lower levels integration environments. But you wouldn't be the first one to actually get rid of it and test things in production. This is an example. Skyscanner famously do it. Does everybody know Skyscanner? Yeah. Who knows Skyscanner? Yeah. Who doesn't know Skyscanner? Okay, good. I did a talk in the States a while ago, and I talked about Skyscanner, and no one knew it. And I actually had to explain what they do. But that's not today. That's good. So anyway, Skyscanner is famous because they do not have a testing environment. They just go from local development to production in one go. And whatever they can test locally, they test locally. And whatever they cannot test locally, they test in production. That's it. Now, you might be able to say, well, they can do this because the business model is a bit different to mine, because they don't actually hold that much critical data. They're just grabbing flight prices on the fly from other places and presenting them to you. So, you know, you're not going to corrupt data if you do something wrong. You might just be showing wrong information, but that's not even your problem, because whenever someone books a flight, they don't book it on your website anyway. They go to the other place. So if I gave you the wrong price, sorry, I'm not the authority anyway. You have to go to those places to buy. So you might be able to say, yeah, they have a low-risk operation, so they can afford to test in production, et cetera, et cetera, et cetera. And maybe you think, my operation is much higher risk, so I cannot do this. And you might be right, but still, if you look at your entire architecture, you might see that some parts of them are critical, some parts of them are a bit more, lightweight. And maybe you cannot afford to do testing in production for your entire system, but you can test in production some parts of it. So maybe you cannot afford to get rid of the entire own integration environment, but you can make it smaller. And making it smaller also serves the purpose of simplifying your operations, simplifying your testing, and reducing your bill. If you're still thinking, no, that's wrong, testing in production, that's just unprofessional. Well, try to think of it this way. Have you heard of the Chaos Monkey? Yeah. Okay. Who has not heard about the Chaos Monkey? Okay, a few people. This was an idea popularized by Netflix a few years ago. At the beginning, they went full on, and they had a Chaos Monkey and a Chaos Gorilla and a Chaos Kong, and they call it the Simian Army. They spent a lot of design and marketing just on this. It's very funny. Now they got rid of most of it, or it's just the Chaos Monkey left. And it's called this way because it mimics, if you have a data center and you just let loose a monkey, and the monkey just starts, causing chaos and pulling cables and pissing on top of the servers, etc., what's going to happen? It's going to be random things all over the place, right? And that's what the Chaos Monkey does. It's a program that just goes to your environment and starts crashing things. And it might just corrupt a database, or it might make a Kubernetes port disappear, or it might crash a Java virtual machine. It just breaks things randomly. And the idea that Netflix had behind it is, if you build your system to be resilient, then these things won't matter. But you need to make sure that your system is resilient. Now, when they wanted to test whether the system was resilient, it's very easy to make things work in test, because you don't have the kind of traffic and pressure they have in production. Particularly for a company like Netflix, you cannot mimic the level of traffic that you have in production in a lower environment because you don't have millions of simultaneous viewers all over the world. So they said, we're just going to test this in production. We're just going to throw the chaos monkey in production and see what happens. And what happens is sometimes they broke things for real, and they learned a lot. And they learned when they thought the system was resilient, and it actually wasn't. The idea of chaos testing is something that is getting a bit more popular, and more companies are doing it. And when you think about it, the chaos monkey answers the question, what happens when my database crashes? What happens when my posts disappear? And answering those questions is testing. The fact that you do it in production proves that you can do testing in production. You just get to get comfortable with the idea of testing in production. So if you do get comfortable with the idea of testing in production, then you can get rid of their own integration environment, or at the very least, you can make it smaller. Last but not least, let's go to performance. Performance is a bit of a funny animal because most organizations that I've seen, even though they're very agile, they're very modern, etc., when it comes to performance testing, they still have a different team that does the performance testing. Sometimes it's even a different company altogether. They hire someone external to come in and say, hey, can you performance test my system and tell me what's wrong with it? Right? And then these people would come with the big guns, and it's like, yeah, I'm going to throw all these many requests to your service, and I'm going to break it, or I'm going to see if I can break it, etc., right? And because of this, you typically do it in a different environment. You have your performance testing. Why? Because when you have people coming here with the big guns and hitting your service that way, you might knock things over, right? You might break things. And if you have your QA engineers testing a new feature, or if you have someone demoing your new feature to a stakeholder, you don't want that demo to crash just because someone is doing performance testing, right? So that's what you do it aside. You say, look, you're going to do all these playing out there, do it out there. Right, so the problem is that with our ordinary testing, we just have a few users. We may have like 2-3 concurrent automated tests plus a couple of testers doing a bit of manual testing or exploratory testing, plus maybe the product owner doing a demo, etc. It's just, it's very low traffic, easy going, etc. And then the performance testing team comes and they go, now I'm going to hit it with 5,000 requests, all going pa, 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 pa. And here's the thing. This is Agile on the beach, right? We're very agile. And one of the main things about Agile is work in small increments. We keep saying these things. You have to have short feedback loops. You have to release often, get information back quickly. You have to learn quickly. You have to adapt. You have to respond. You have to work in small increments. And then we go to performance testing, and we go from 5 to 5,000 users in one single go. And that's the problem. The problem is we're making a leap that we ourselves are saying that we shouldn't do. We say, do not do a Big Bang approach. And then with performance testing, we do a Big Bang approach. We just go big straight away. And the answer is, do not go big straight away. Go little by little. Do not go from 5 to 5,000. Go from 5 to 10, to 20, to 50, to 100, etc., etc., etc. And most importantly, do it as part of your normal business. Do it as part of your normal stories or tickets or tasks or however you measure your work. Whatever you do, make sure that performance is just another of the tasks that your team does. Now, Steve did a talk this morning, very useful. Thank you. And one of the things that he mentioned was about not getting rid of your DBAs, right? Your DBAs are just going to help you. This is a similar thing. It doesn't mean that you get rid of your performance testing experts. It means that instead of being someone outside of the team doing their thing independently from the team, you bring that person to the team to help your team prepare the pipeline to automate the kind of performance tests that you need to do. And you do that little by little. So you have one task that is, I'm going to increase the performance testing to 100 concurrent users. And you do that. And you are unlikely to break things when you with this small increment. Things might get a bit sluggish, things might get a bit slow, your queue mechanism might get long queues and it may take a while to process them, but you're not going to break things, which means that if you're doing this in the same environment and the PO is doing a demo, well, it might get a bit slow and that's not great, but it's not the end of the world. And actually, it might actually be beneficial. When two testers are testing different pieces of functionality independently, they usually test them in the same environment. They don't get each of them one different environment. Imagine if they said, no, we want to test these functionalities independently because what if we affect each other? Well, if you affect each other, that's something that you want to see. Because when you go live, you're going to have users doing things at the same time. And if that is a problem, you want to be able to see that. This is the same. If your performance testing is going to be an issue for your functionality testing, then you want to do that at the same time because you want to see that problem and you want to fix it. And like I said, if you do these small, little by little, and you create your automated tests and you add them to your normal suite environment, to the normal test suite, then you will realize that you can do performance testing together with all the other tests. So you do not need a different performance test environment. So the key here is we need to start talking about continuous performance testing. It's not something that you do as a one-off with a different team in a different environment. It's something that you adapt as one of your practices, is one of your tasks, is one of your objectives, one of the things that you need to do. Once you do that, you realize that you do not need a separate performance test environment. To summarize, first of all, more environments means more problems. Some of these problems are managing all the different features in all the different environments, which you can address with having universal feature flags. The second one of this problem is very similar to the first one, which is the problem of managing your tests, your automated tests, which you can mitigate by having meta automation. And then the third of your environments is, the third of your problems is the proliferation of different environments with all the complexity, operational costs, etc. that comes with that. And the way to fix that is taking a hard look and making sure that you have only what you need and no more. And then finally, most importantly, enjoy the journey. Getting to this point is not easy. It's a lot of trial and error. It's a lot of, again, working in small increments. So do not think that you're going to get to this point tomorrow. Sorry, enjoy the journey. I forgot that. Do not think you're going to get this immediately tomorrow. It's going to take a while. And maybe you didn't even get to this point, but that's fine. The point is, 1 year from now, you need to look at today and see, actually, we got better. We applied some of these ideas, and we got better. So here's my hope to you, that you get some of these things, and it helps you, and then you go back to your teams, and 1 year from now, you look back and you say, you know what? We did get better. Thank you. Are there any questions? Yes, I see a few hands. Do we need microphones for them?
So you mentioned, is it even on? Hello? Oh.
Yeah.
So you mentioned feature flags as a service, and the concept seems like a good idea. But doesn't that potentially introduce a single point of failure? So if that microservice where you're receiving your feature flags from, where you're sending requests, if that's not working, then nothing's going to work. So why would I want to perhaps do feature flags as a service rather than within the application? Of course, multiple environments, but how do you deal with that failure point then?
That's a very good question. The thing about single point of failures is that when people utter this phrase, single point of failure, we all go, oh my God, a single point of failure. But actually, we have plenty of them all the time, right? You have one database, that's a single point of failure. If the database crashes, nothing works. You have, maybe you have one proxy coming in, your ingress, that's a single point of failure, et cetera, et cetera. So you do with this the same thing you do with all the other single point of failures, which is You check how often it actually breaks to see how much of a problem this is. And then you talk mitigating strategies, like for instance, service degradation. If I'm a service that has a fork of 2 different code branches, depending on the value of a feature flag, and I talk to the feature flag service and it's down, what do? Well, I could have a default value, and maybe I say, well, I'm going to talk to the feature flag service to see whether the feature is enabled or not, and if I don't get a response, then I'm going to assume X. And what that X is depends a bit on your business. My suggestion would be, by default, in production, your flags should be off, because I'm assuming that the fact that you have a flag is because you want to delay the enabling of a functionality. If it needs to be enabled straight away from the beginning, then maybe you don't need the flag at all. And if your flag is on in production, then typically that flag shouldn't live very long. The moment something is on, then probably you want to delete the flag and just make the on functionality the only functionality. So chances are you can apply some of these strategies, particularly service degradation, just to say, if we have, if I don't have a value, then I just assume a default.
Abraham, thank you.